Today we're going to talk about similar triangles. We've talked about proportions, ratios, and similar figures. Now we're going to talk about similar triangles. When we start talking about similar triangles, we first need to talk about the types of triangles that can be similar. First, we have angle similarity, which says if two angles in one triangle are congruent to two angles in another triangle, then the triangles are similar. If we have two angles in one triangle congruent to two angles in another triangle congruent, they have to be similar. Next is the side-side-side. If the measures of the corresponding sides of two triangles are proportional, then the triangles are proportional, which means they are similar. Side-angle-side similarity. If the measures of two corresponding sides of two triangles are proportional and the included angles are congruent, then the triangles are proportional, which means they are similar. Let's try and use these different theorems we have here. So in this triangle I have a 52 by 89. In the other triangle I have an 89 by 39. We need to figure out, are these triangles similar? We can start with either triangle. I'll start with the one on the right. We have an 89 by 39. If we add the 89 and the 39 together, we'll get 128. Since it's a triangle, we know that the angles of a triangle must add up to 180 degrees. So if we subtract that from 180, we're going to get that this angle that's missing would have to be 52 degrees. We actually do not have to go any further. We have the angle with an 89 matched up to the angle with the 89. We have the angle with the 52 matched up to the angle with the markings of 52. We have angle-angle similarity. So we have enough information to say yes, these two triangles are similar. Next, we have two triangles. The first triangle measures 6, 9, and 12. The second triangle measures 2, 3, and 4. Now immediately we should hopefully be able to see that the only way these triangles can be similar is through side-side-side. I'll match them up. The shortest side on the first triangle over the shortest side on the second, the medium over the medium, and the large over the large. If we divide all these out, we get 3 equals 3 equals 3. So we would say yes, these triangles are similar because of side-side-side. Next, we have two triangles that are two sides and one angle. Well, we have the angle, that's okay. Now let's compare the sides. I have 12 over 6 and 15 over 7.5. If I divide those out, I get 2 equals 2. Again, these triangles are congruent. The reason is side, angle, side. Next, we have two sides and an angle again. So we think we should be able to try side, angle, side. The problem though is, remember, the definition of side, angle, side is that the angle is included between the sides. That means we would need the angle at the top or between the two sides. If I trace the side with the 18 and I trace the side with the 24, the angle would need to be between them. It is not. Therefore, we can stop right now and say no. Even if the sides are proportional, the angles are not in the right spot, so we cannot say that these are similar. Which triangles are similar? They all have right angles, right? None. Just because they're right triangles does not mean that they are similar. We need more information than that. We have no similar triangles in this picture. Find x. Well, in order to do that, we need to have some reasonings that we could try and solve it with a proportion. If we look at the picture, we can mark these are congruent because of vertical angles. We also have parallel lines. If you remember back to what we've learned before, parallel lines cut by a transversal, these two angles then would have to be congruent. So these triangles are similar because of because of angle, angle. Now we can set up our proportion. We have 10 over 4 equal to 2x plus 10 over x plus 3. Now we have our proportion, we can cross multiply and solve. We have 10x plus 30 when we cross multiply from the 10 to the x plus 3. Then we go the other direction, we get 8x plus 40. If you're not sure how this works, make sure to ask me in class. This is going to be really important to understand how to set these proportions up and how to solve through cross multiplying. Now subtract your 8x from your 10x and you get 2x. Subtract your 30 from the 40, you get 10, and you end up with x is 5. And we've solved the question. It wanted to know the value of x. Our last example here has something to do with the sun. We see shadows. We have the ratio of the man standing is 6 foot. His shadow is 4 feet. The building when it's standing has an unknown height. The building when it's laying on its side is 55 feet. So we have actual over shadow, actual over shadow. We will simply solve this by cross multiplying. 6 times 55 gives you 330 equal to 4x. Divide by 4 and you find that the building is 82.5 feet tall. We solved a lot of things today and had a lot of example problems. If any of those example problems are causing you problems, please come in and talk to me and ask me about any of them. I'm happy to help you. Just make sure to ask the question.